Okay, let's continue with this. So let's talk about magnitude. The magnitude is the size of the vector. In physics, you might talk about like the newtons or force. In this class, we're going to talk about the distance. So let's take something really interesting. 3, 4. So we look at, it's 3 to the right and 4 up. The question is, what is the magnitude? Well, if you notice, this is a right triangle. And so we can see here that the magnitude, what they'll call r, so we have r squared is equal to x squared plus y squared. So r is equal to the square root, the positive of x squared plus y squared. And so in this case, the magnitude of 3, 4, which the notation we're going to use is like absolute value of 3, 4 is equal to 5. And so that's how we find the magnitude. It's very straightforward. And so you can find the magnitude of all of these. Now, it's really interesting because, so for example, you can find the magnitude of all these, but I want to bring up I want to put a bunch of factors on which to make a point. I want to put 3, 4, negative 3, 4, 3, negative 4, and negative 3, negative 4. So the question is, what is the magnitude of all 4 of these vectors? And the answer is the magnitude for all of these, let's call this A, B, C, and D. The magnitude of A is 5. The magnitude of B is 5. The magnitude of C is 5. And the magnitude of D is also 5. But, and we'll talk about this a little later, they all have different directions, but they all have magnitudes of 5. And what we're moving towards, like trigonometry, is like we're on a circle whose radius is 5. Right? Imagine the radius is 5, but these are all, so this is 3, 4. This is 3, 4. This is 3, 4. This is 3, 4. And this is 3, 4. Negative 3, negative 4. This idea, this is what we're moving towards. All of these have magnitude 5. But they're going in different directions, and that's what I want you to hold. I want you to, once again, bring the trig in. So, and let's think about this. Let's look at A versus D. Well, they're opposite, right? This was 3, 4. If we multiply by negative 1, we got negative 3, negative 4. We got an opposite vector. What's going on with B and C? We can see they're opposites because negative B, which is negative 3, 4, is equal to 3, negative 4, and that's equal to C. And these are the relationship of the vectors we're moving towards. So once again, the magnitude is just like the hypotenuse of a triangle. Now we're interested in vectors with unit 1. Right? So we're interested in vectors. We're interested in vectors with magnitude of 1. Now this is kind of interesting. We're interested in all the vectors that are on the unit circle. We're interested in all of these vectors, right? All of these vectors have magnitude of 1. But let's talk about the simplest ones. What's the easiest vector that we can think of that has unit 1? Well, 1, 0 has a magnitude of 1, and 0, 1 has a magnitude of 1. These are the unit vectors. And so we're going to call 1, 0 I, and we're going to call 0, 1 J. Okay, and what we're moving towards is this representation of vectors into something called components. Okay, it's basically not moving fast, but I'm really not. It's just very basic algebra. You'll follow it in the Hess book. So, for example, what you're going to be doing is, so we talked about in the last unit about vector addition. So, for example, I asked you to add, 3, 1 plus, 2, 5. Well, we're not going to represent this anymore. We're going to take 3, 1, and we know the answer is 5, 6, right? But let's do a different representation. Now 3, 1 is equal to 3, 0 plus 0, 1, which is equal to 3 times 1, 0 plus 1 times 0, 1. We're going to call this 3i plus j. And we're going to call 2, 5. We're going to break it up into its x part, and we're going to break it up into its y part. And so we have 2 times 1, 0 plus 5 times 0, 1, which gives us 2i plus 5j. And so now we have these many different reps. So now 3i plus j plus 2i plus 5j is equal to 4i plus 6j. And sorry. 5i plus 6j, which was our 5, 6. So what we're talking about is different ways of representing. Now, what did I do here? Well, this is just scalar multiplication. If you think about it, this is 1, 0. We can take this and multiply it through, right? So let's just talk about this scalar multiplication again. Multiplication of vectors. So the first one we said 2a was a and a, but if a was equal to 3, 4, then 2a is equal to 6, 8. Now, yeah, very basic. That's the idea, and that's basically it. And then, yeah, that's it. So, and then you can just add all these together. So the idea is, for example, and I'd say, 3i plus 4j plus 6i minus 7j. Well, that's equal to 9i minus 3j. So the first journey plus the second journey. What happens if I say 5i minus 2j minus 3i plus 4j? Well, what's going on here? Well, it looks a little confusing. First of all, the algebra is the algebra, so we have obviously it's 2i minus 6j. Well, what's happening here? Well, the first journey is 5 to the right, 2 down. We're doing the opposite of 3 up. 3 to the right, 4 up. 3 to the right, 4 up. So it's 3 down, 3 to the right, 4 down, which gives us our final displacement of 2 to the right, 6 down. And that's basically it. It seems very straightforward, and you think it should be advanced. We'll get to the advanced stuff. Chapter 14 is just very, once again, this is like 6th grade stuff, 7th grade stuff. And that's it. I don't want you thinking, this is too easy. The first part is easy. Once again, you never saw this before. What else do we have to do? We did magnitude, unit vectors. Let's see. Find k such that I don't know. 1/2 k is a unit vector. Well, some of you should immediately look at that and be like, wait, I know the answer to that. Yeah, see, find k if 1/2 k is a unit vector? Some of you should look at that and be like, I know that. I know the answer. Anyone know the answer? Yes? Yeah, correct. Yeah, k is radical 3 over 2. And some of you say, oh, wait a minute, I recognize that from the unit circle, the 30, 60, 90 triangle going around the unit circle. Well, we could figure it out. We say, fine, the square root of 1/2 squared plus k squared is equal to 1. We have 1/4 plus k squared equals 1. K squared equals 3 over 4. K equals radical 3 over 2. Actually, there's 2 answers, right? Right? 2 answers. Yeah. Adding, subtracting, scalar multiplication with vectors. What else do I want to talk about? I'll hold off on that. The next thing we're going to do is we're actually going to put the vectors on graph paper. I'm going to tell you that point A is like 1, 2, and B is 3, 4. Find the vector. That's the next unit.